Hey everybody, it's Tracking Pat, and today we're in the assembly area because we're going to do an instructional video on the TRAK 1440EX lathe. Now we don't get very many opportunities to do videos on this because we don't have one in the showroom that we can use. But it just worked out today that we have a machine that's been completed, so before we ship it out the door, we're going to teach you a little bit about how this thing works. The 1440 has an ELX control on it, which also is different than most of the other controls that we do videos on. It's a simple product, but it's still very powerful. You'll find most of these machines are in the learning environment, so a lot of schools, universities, and teaching facilities have this product in there, and they don't have any videos to work with. So therefore, we're going to make this video and hopefully get you guys up and running, okay? So what do you say we get started? Okay, so here we are, and we are at the main screen on the TRAK ELX. And I've got a certain way that I want to teach this so that you guys get all of the important information throughout the different modes. And I am going to start in the setup mode because I think that's the easiest place, because quite frankly, without your tool setup, you really can't show how to do much of anything. So we're going to start right there, okay? So you'll notice on the screen, very similar to a lot of our other controls, you've got your different modes of operation here, your inkset, abset keys, and all of that go and stop and stuff that you're already used to, okay? What I'm going to do is I'm going to come down here to the setup mode, and you'll notice the first button here says tool setup. So I've got 3 tools for this part. I'm going to do a right turn face tool, I'm going to do a grooving tool, and then I'm going to do a threading tool, all to the OD, okay? So I'm going to go to tool setup here, and it's asking me for a tool number. And I'm just going to use this as tool number 1, set it up like so. And then I'm going to set this first tool. And you'll notice that number 1 in the list, like all of our other lathes, is a right turn face tool. So that's the type of tool. And now it needs to know what the diameter is that I'm going to set it at. Now keep in mind that the 1440 is a geared head machine. Therefore I have to set my feeds and speeds manually. And it is a little noisier than some of the other machines too, so I'll try to talk over the noise as I'm going through things. But in case you can't hear me so well, let me just tell you what I'm about to do. I'm going to take a cut, measure the diameter, punch it in here, face off the end of the part, tell it that's Z0, put in the radius of the tool, okay? So here we go. I've got my first tool here like so. I've already set my heights so that they're on center to make it a little easier. The switch is here in the middle between the hand wheels. So I'm going to turn it on right now. Just take a little bit of a cut and then measure what I've cut. I'm at 992, like so. Turn it back on to do the Z. Z0, and then the radius of this tool is 0.031. Okay? I'm just going to push return, go to tool number 2. That tool is going to be a grooving tool, okay? Now, keep in mind that the ELX doesn't really have a grooving cycle, okay? So because of that, they also don't list an actual grooving tool. So I'm going to set it up like a right turn face tool, but it's going to be a different tool. So I'm going to take tool number 1 off, take my 1/8 grooving tool here, like so. I'm going to also tell it it's a right turn face tool, even though I'm kind of lying about it. I set it up the same way, all right? Okay, it's at 0.985. Z0, okay. And I actually have to think about the width of the tool in my head as opposed to a real grooving tool where I tell it how wide it is, okay? There's no radius, so I'm actually done here. And then tool number 3 is going to be my OD threading tool. Okay, so one more time, tool number 3. Number 7 is my OD thread tool. Same scenario. Okay, so I'm going to just use the same diameter that I just touched here. And I've got all 3 tools set up, okay? So that's the first thing, is to have your tools set and available. The second thing that you want to do is whenever I've set my tools, I want to remember to save my tools, okay? So if I push return here, you're going to notice down here the 4th button down says Save Tools. And what that does is it burns those tool offsets to the memory of the machine and the control, so that when I turn it off and turn it back on, I only have to take one of the tools, establish where my 00 is, and all the tools will work from there, okay? So now that I've got my tools set up, the next thing I want to do is set my home position, which would be my tool change position. And you'll see in here also that the 3rd button down says Set Home. Now right now it's telling me that the status is that the X and Z home positions have not been set, which means if I forget to do this for any reason, when I go into run mode, it's going to say, hey, you have to set the home position or I can't run, okay? Because it doesn't want you to send your tools to 00. I'm going to simply set it at 6 for a diameter and also 6 away in the Z axis. All right, and that's going to give me my home position for that. Okay, now I'm going to come back to the setup mode after I make a program to show you how to check your tool path and stuff like that. But for now, I want to get started with showing you how to do some of the other functions that we have, okay? So I'm going to go to the DRO mode. So I'm going to get out of here by hitting the mode screen, go to the DRO mode, and you'll notice in here I have the ability to jog the machine, use the do one functions, the go to functions, return it to home, all of that kind of stuff. All right, now I do want to tell you one other thing, which is the fact that for the sake of the video, we have a jumper on the door guard. Remember that all of our products will not move by themselves with the door open normally, okay? But in order for the video to be able to see what's going on, we had to do that, which means think of it as the door closed right now. If I tell it to return home, it's going to tell me when you're ready, push go. And when I push go, it's going to move to that 6 and 6 position, okay? Now I've still got tool number 3 in here, and this is very important. If you look at the very top, it's telling me that we're in DRO mode, we're in the coarse feed for the hand wheels, and also that we have tool number 1, or number 3 in there, and that we're working in inches. So first thing I'm going to do is I'm going to put tool number 1 back on here. And of course, the machine has no way of knowing I did that. So I need to come down here where it says tool number and switch that to tool number 1. And you'll notice that my DRO has changed for that particular tool. Okay. Also, I do want to talk a little bit about what I was saying about coarse feed. So up here, you're going to notice that on the control here, way down in the lower right-hand corner, there's a fine and coarse button. And you'll see it changing here as I push that button. In the fine mode, it works just like a normal hand wheel on any machine tool. One full revolution is 200 thousandths, and then when I go to coarse, it's 800 thousandths. So it just makes it so the hand wheels can get you faster and then get back down to a fine feed so that you can use it properly, okay? Now we've got some features that are really handy in here in the manual mode, and the first one we're going to talk about is just the jog. So when I go to jog, you'll notice that a red button comes up and says, hey, jog is now active. Okay, so now if I wanted to move the Z-axis, I would just push the Z-axis and it'll move as long as I hold the button. Changing direction, just hit the plus/minus key. It'll go the opposite direction. And of course, the return key takes it back out of the jog mode. Next thing I want to show you is how the do one features work. In the do one features, I have the ability to cut a taper, a radius, or a fillet. And I've also got a power feed function in there if I need to make it feed by itself, okay? So first of all, let's talk a little bit about how the taper works. So if I move the machine over to a specific spot like so, I'm going to bring it in just to Z0 here. Okay, and let's say that what I want to do is cut a taper right here. Then I go to taper and it says, what do you want to cut it at? It assumes 45 degrees. So if that's what I want, I just hit the set key. If I want it to be 30 or 25 degrees, I just punch in a different number. Once I do that and I turn the spindle on, turning the hand wheel cuts at a 45. So as you can tell, it'll continuously cut at a 45 as long as I turn the hand wheel. Now when I'm in the Do One features, my Z-axis hand wheel is actually my coarse feed and my X-axis hand wheel is my fine feed, so I don't have to switch back and forth all the time. Once I push return, the hand wheels work normally again. So as you might guess, I've got other features in here too, right? I can cut a radius. And I'm not going to cut this time. You'll see how it works on the camera though. If I say I wanted to cut a 1-inch radius, now what's going to happen is as I turn the hand wheel, it'll cut 90 degrees of radius in either direction, right? If I wanted to push return and say put a 1-inch fillet in here, it's going to do the same thing, only it's going to cut an ID radius, right? So these functions in the Do Ones actually replace your compound that will be on a manual lathe, all right? Last but not least, your power feed basically just says, what do you want to move and how far, okay? So if I wanted to use the power feed in the Z-axis and I was touched on my part already, I could say, hey, you know what, I want to move the Z minus 1 inch. That's an incremental dimension, so it's going to ask you for the answer in incremental. And then when I push go, it's going to move accordingly 1 inch from where it was sitting to wherever I tell it to stop. And I can adjust the feed of how fast it's running with the up and down arrows if needed, okay? So that pretty much covers the DRO mode except for the go-to feature, okay? The go-to feature, if I push return, is just an electronic stop that you have in the hand wheel. So what it allows me to do is program a number in there and I don't have to watch the readout to cut it. Let's say that I wanted to cut this part down to say 950 thousandths. In the go-to, I would say put the X at 0.950. And then let's say I wanted to also cut a 1/2 inch deep in the Z. So I put the Z at minus 0.5. You'll notice in the green box, those are the numbers. So when I turn it on, you're going to see that as I machine, when I get to those numbers, the hand wheels will keep turning, but the machine will not move. Okay, so I'm going to turn the spindle on. Actually, let me get over here first and then go back in. One of the nice things is it remembers the numbers all the time. So you'll see as I turn the hand wheel in, it stopped working when I got to the 950. And when I machine this direction, it disconnects that way too. So again, if I've just got some material to remove, I don't need to make a program for it. I can just simply come in here and program these features and then it'll stop every time it gets to those numbers. When I push return, now it's full manual mode again. All right? So the next thing we're going to do is we're going to make this piece part, okay? And I've got a sample of it right here. And as you can tell, this is a part that you've probably seen in other videos I've done before. It's what we call a small spindle. It's got a part out of 1-inch stock that has a taper in it, a groove for thread relief and some threading and stuff like that. And I'm going to show you how to do this. This will give you all the basics that I think you need to have, all right? So to get started, I'm going to change modes and I'm going to go to the program mode. Now, since the ELX is such a simple control, it doesn't allow me to name files with names and alphanumerics. It only allows me to use the numeric part, okay? So I'm just going to call my program number 123 for now. And now I get into the meat of the programming. So here's where my positions are, my drilling and boring, my turns, my arcs, and under the more key, my cycle events, my threading, and my repeat, okay? So what I'm going to do first is I'm going to explain how to do the facing of the end of the part, all right? So that's a simple turning event, which is the same thing as you might want to think of it as just cutting a line from point A to point B. So I'm going to start just outside of my material, so 1.1 and Z0, and then I'm going to go to a -0.1 and Z0 to face off the end of the part. It's asking me if I want to put a chamfer in here, but that's only used if I'm connecting them together. So I'm going to leave that at just 0. My tool offset, it asks where's my tool compared to the part. Here's my part. My tool is to the right of it as I face the part. Number 1 for right. Feed rate, I'm going to run it at 10 inches a minute. And tool number, I'm going to use tool number 1. So you'll notice if I push the look button, now I've got a little blue line there showing the facing of the part. Push the look button again, it goes away. Next thing I'm going to do is a cycle event. For those of you who are not familiar with a cycle event, basically it's like doing all the roughing parts and the finishing and all the feeds and speeds all in one, and you just kind of start out by giving the description of how to remove the material, and then you describe the finish dimensions piece by piece, and then the stock, and it creates the tool path to do it all. So I'm going to select cycle. It's asking me for a beginning point. I'm just going to start at 300 in the diameter and Z0. And it's asking me a number of passes I want to rough it out with. Let's just say that we want to do it in 8 passes. We're going to use the Z axis to do the roughing. I could also use the X axis if needed, but in this case, Z makes more sense. I'm going to use that same 10-inch feed rate. Okay, I'm going to use tool number 1 still. Finish cut, I'm going to leave 10 thousandths for the final pass. My finish feed rate is in there as well, and this is still tool number 1. So I can have a separate tool to finish if I need to, but in this case I really don't. So I don't know if you'll be able to see this on the camera, but there's a little dot there showing where I'm going to start. And now you'll notice that the screen has changed to say cycle turn, cycle arc, cycle position, and so on. I'm going to do a cycle turn, which is another straight line inside the cycle, and it says where do I want to go? Remember over here on the left, I started at 0.3, so I'm going to go to 0.5. Leave it at Z0, and the chamfer is going to be 50 thousandths according to my print. Okay, so now I've got a straight line coming out to my first diameter, and it says, what do you want to do next? I'm going to do another turning event. As I show you guys in a lot of videos, I like to use Inkset as a no change key. It's asking me for the diameter at the end of this cut, and it hasn't changed from the last time I told it was a ½ an inch. So I'm going to use Inkset for no change, and then put in my minus 0.937 as the length in the Z-axis. And there's no chamfer or Conrad at the end. Keep in mind, every time it asks for a chamfer, you can get a radius if I just use the Inkset key instead of the Abset key. In this case, it does not apply. As you can start to see in green, you're seeing my part as I'm making it, right? So I've got another turning event. It's a tapered part, so it's going to go to 0.868. And the Z dimension is minus 2.657. And at the end of it, you're going to see in the print that the radius is 0.05. So again, this time I'm going to use the Inkset key, and you'll see over here it says Conrad for that radius. Next thing I'm going to do is come out to my finished dimension, which is 1 inch. So another cycle turn, go to 1 inch, don't change the Z. There is no chamfer, and you'll see here, you're starting to see my completed part. According to the print, the part is actually 4 inches long, so I'm going to make it that way because this is more about instruction. Really, the part's already 1 inch, so I don't need to do this. And the bad part is I got to leave the part hanging out pretty long, and that's why you kind of hear some of the chatter and things like that. Hopefully when we get to cutting, I get the feeds and speeds right, and it'll be okay. But for now, I'm just going to show you that I'm going to do another cycle turn. I'm going to leave it at 1 inch, and I'm going to go to the full length of minus 4 inches, okay? There's no chamfer here, so when I look at it, you'll see the completed part. And now what I'm going to do is I'm going to use a cycle position, which basically is helping to describe the material. So I go to cycle position, the X doesn't change, it's still 1 inch, but the Z is going to come back to absolute 0, so I'm going to use the absolute set key, and when you look, you'll see there's a dotted line here now describing the material. And the last thing I have to do is end cycle. Now when I say end cycle, it tells me, hey, the loop is not closed. You can either do it yourself or just have me do it. I'm just going to say, yes, you do that for me, and that completes the cycle event. The next thing I'm going to do is a groove. As I stated in my tool setup, the ELX control doesn't have a grooving tool. So I'm going to use that tool number 2, but make the groove myself. So here's what I'm going to do. I'm going to do a turning event. I'm going to start just outside of my material, which is a ½ inch now. So I'm going to start at 0.550, and I'm going to go to that minus 0.937. And my X end is going to be the minor diameter, which is 0.450. and the Z is going to stay the same, so no change. There's no chamfer because I'm not connecting it to anything. And my tool offset is still to the right of that 937 dimension, okay? So tool number one, or part number one, sorry, not part number one, but side number one. Feed rate, I'm going to slow this down. In fact, I'm going to actually slow this down to maybe 2 inches a minute. Use tool number 2. And when you look, it's kind of hard to see, but there's a little spot in there where it's doing that small groove, okay? What I want to do now is I want to position back out of the material so I can move over, because my tool's an 1/8 wide, but my groove is 3/16. So I'm going to come in here and just do a position event and say, hey, bring the X back to 550. Keep the Z where it is, no change. And it's asking me when I get there, should I continue on or stop? I'm going to say yes, continue. Use tool number 2 still. And now I've got that little move to make the groove and a rapid back out. If I push the more key, I'm going to do a repeat event next. What am I repeating? I'm repeating that turn in and the position out. So it will be from event 10 to event 11. And the X offset, there is none, so ink set. But I need to move in the positive direction 50 thousandths to make my groove the right width. Okay, so that's also incremental from the original lines. Number of repeats, just once, still with tool number 2. And if you look, there's 2 little dots there in yellow that are showing the positions. They kind of overwhelm the actual turn moves, but you know they're in the right place. The last thing I'm going to do is cut a thread. So I'm going to hit the more key again, go to thread, and in here it's asking for my major diameter, okay? My major diameter is 0.5, right? And this is a 1/2 inch 20 thread, okay? So my Z beginning is going to start at 0. My X minor is actually my minor dimension. So if you don't know that, you're going to have to look it up. It's actually 0.4662. My Z end is minus 0.937 because what I'm trying to do is get that threading tool all the way into the thread relief. The pitch is 50 thousandths. I got that by 1 divided by 20 threads per inch. The answer is 0.05. Number of passes, I'm going to use 5 passes. 1 spring pass once I get to the final dimension. My plunge angle is assuming it's a standard 60-degree thread, so it's going to come in at 29.5. I'm just going to hit the set key to accept that. I'm either doing inside or outside threads. In this case, number 2 is for outside threads, and I'm going to use tool number 3. And when you push look, you're going to see that the threads are right here on the part where they belong. So there's the programming part of it. I do want to talk about a little bit of something else. In this video, I'm not going to have the time or the tool set up in order to show you ID work. The process is the same. Just remember, when you're setting up your tools, you're going to have a part that's got a hole in it already, so you can touch your boring bars, your ID threading tool, your ID grooving tool off of a known diameter on the inside. You set up the tools exactly the same way. Okay? So now that I've got that done, what I'm going to do is change modes. And I'm going to go in here and I'm going to look in the setup mode again, all right? Now I told you I was going to come back to the setup mode, and what I'm actually going to show you in here is the only thing that I didn't push in here, which is tool path, okay? And here you'll see I got an error, and this will happen sometimes where I have too many passes in the rough cycle, and because I was just kind of guessing at how many I needed, it says, hey, I'm going to adjust that for you. Okay, which is perfectly fine because it doesn't need the 8 passes I put in there in the first place. But keep in mind, you could also change that by going back to the program mode. Just go to the beginning and then just move yourself forward until you get into here. And it probably only needed like 3 or 4 passes, I'm guessing. So I'm just going to change it just to check it one more time and see if it likes it or not. And there you go. You can see by changing the amount of passes, it actually cleaned it all up and made it where it worked fine. So it knows whether or not what you're doing is overkill, I guess is what I'm telling you. So there's my tool path. You can see all the red dotted lines are going to and from the home position. Everything in here looks great, okay? So the next thing I have to do is go to the run mode, okay? Now, as you guys all know, I'm tracking Pat, right? And a lot of that name comes from the name in the company, as well as that great feature that we have called tracking, right? Well, that is one feature that the 1440 does not have. Okay, so because of that, you're going to use this machine a little bit different than our other machines. When you go to the run mode, Everything looks right on the screen. Everything looks right when you set up your zeros and so on and so forth. So I know it's going to work right. But when you're first learning, you might want to do one of two things. First thing you might want to do is while you're running, have that remote stop go button in your hand. This one's already packed away for the customer, so I don't have that. But the other thing you could do is just run the part without the tool on the tool post and make sure everything looks great, and then just start it over with the tool on there and let it go. I believe wholeheartedly that I've got this thing set up and ready to run. The only thing I'm not too sure about is whether my feeds and speeds are correct. I've got it at 1200 RPM, which might be a little fast for this. We're going to find out when we run it. I'm not really concerned if I get a little chatter because it's more about the instructional part than whether I get a perfect part, and I don't have any coolant in here either. Okay? So I'm going to go to run mode, and in the run mode, you'll notice I have the same two questions that every other control and machine has, which is, do I want to start or do I want to start at an event number? Start means I'm always starting at the beginning, but if I was to come back halfway through the program, I could say, hey, start on event 3 or 4 or whatever. If it's an event that has a rough and a finish, it'll say, do you want to start at the rough or the finish? And it'll guide you through there. We're just going to push start. And at this point, it says when you're ready, push go. So when I push go, it's going to go home. Okay? And then just to protect myself from getting anything thrown at me, I don't want to hide the camera, but I'm going to give myself a little room to stay out of the chips, okay? So it's telling me in here, load tool number 1, telling me to start the spindle, and then when you're ready, push go. So I'm going to push go, and it's going to start making the part. And I'm going to stop it when it gets close just to show you something else, okay? So let me turn on the spindle, and I'm going to push go. And I'm going to stop it right here for a perfectly good reason. I can tell here from my numbers that I'm in about the right place, so I feel comfortable with it making the part, okay? But I also want to show you that you have an Inks Abs button in here. And if you change this button right here, what it usually will let you do is walk down and see it counting down to 0 as opposed to running. So let's push go and let it cut. I'm going to stop it for a second because I can tell by the aggressiveness of those cuts that with the part hanging out that far, I'm going to have a problem with it cutting. It's going to move that part. And that's going to cause me to have a crash or throw the part or something like that out of there. And we don't want to do that in this part of the process, right? So what I'm going to do is I'm going to go back and I'm going to alter my the way my part is held, and I'm also going to alter the program just to make it more sturdy, okay? And this is a good thing for you to learn anyway, so why not do that now? Okay, and I'm going to just go out of here and I'm going to go to Dro mode, and I'm just going to move this out of the way. I'm going to unbolt my part here for a second. And I'm just going to chuck it up tighter. Okay, now what I'm going to do is I really only need to cut the main part of this about 2 3/4. So I'm going to hold it accordingly. And by doing that, it'll be a lot more sturdy. Now I'm also going to change my program, and this gives you an idea of what it's like to edit here, right? So I'm going to go back to my program, go to the beginning, and I'm just going to move forward to the cycle. And as I go through the cycle, what I'm looking for is right here, I'm at the diameter of 1 inch, okay? And from here, I don't need to go that 4 inches. So I'm just going to push delete event. And what you're going to see when you look at it is now I've just got the cutting part of this, okay? So I've deleted the event that goes down to 4 inches. Therefore, I can chuck the part shorter, all right? And now that I've done that, that will work perfectly fine, except I have one more thing I got to do, right? I just changed my Z0, didn't I? So the great part about learning from this experience is now I'm going to go back to DRO and I'm going to reset my Z0. All right, so I'm going to just simply come in here, turn the machine on again. And right here, I'm going to say that I've got a new Z0, right? So I'm going to say Z, absolute 0, and now I'm ready to start again. Now, I don't really have to start with the facing part of it because that's already done. So when I go change modes and go to run mode, I'm going to say start at event number 2. Notice here it says rough or finish. I can't start on a specific cut of the rough, but I can just go to the rough itself. It's going to cut a little air. Might cost me another 10 or 15 seconds. That's okay. So when I push go, it's going to go home. Okay. And once again, I'm going to start the spindle. Whoops, I always forget it's over here. And then push go. So as you can see, it cut the whole outside of the part. I might want to check one thing now just to be sure and see if my diameter's coming out the size. When I look at it, it's right on the money. Okay, so it's telling me load tool number 2. I'm going to go to tool number 2 here, which is my grooving tool, right? And I'm also going to slow the machine down a little bit for this part, okay? So I'm going to go into here to 640, which means that I got to be on position number 2, right? Forgot about the old geared heads. There's a little more work involved in that. 640, and then also on number 1, right? So let's get me all the way over there. Okay, turn the spindle on. All right, and now I'm ready. I'm going to push go. Keep in mind that it's always going to go back home and shut the spindle off. You have to reset the spindle switch in order to do the last part. Okay? Now, I'm going to slow it down a little bit more, even so, to do the threading. Okay? Just to be sure. But I think by doing that, I can just go from position 2 to position 1, like so. And that's going to allow me to run at a slower speed so you can see it do the threading, because I don't have any coolant, right? So it looks good here. I'm going to push go. Okay, so as you can tell, it cut the whole part. I've got my tapered part, I've got my groove, I've got my thread, everything else is done. However, when I look at it, I can see that the thread didn't cut deep enough. That could be from a couple different things. One, it could be because maybe I didn't set the tool up well enough that I'm not getting the full depth of my thread. The other reason could be just the fact that threads are generally set up to have a radius in the bottom of them, and I'm using a pointed threading tool, so therefore it's not deep enough. I know from experience that a lot of times when I set it up and I look at it like this, it probably needs to go in another 10 to 15 thousandths, and this is a good learning point too. So what I'm going to do is hit the mode key. I'm going to go back to setup, and I'm going to go back to tool setup, and I want to talk about tool number 3. So I go to tool number 3, and here it says, do you want to set a new tool number 3 or just edit an old one? I want to edit the old one. And then very important, I don't want to reset where I set it originally, so use the down arrow key and come to the X modifier. I'm going to say go negative 10 thousandths and modify that tool in. Very important to remember, after you make a modification, return out and then save the tools again so it remembers what you modified. Now, I'm going to go back and just recut the thread, but before I do, I can't quite remember what my last event was. So I'm going to go to the program mode and just push go to the end, and here I can see that it's event number 12. So I'm going to change modes, go to run, say start at event number 12, and it says when you're ready, push go. Then it reminds me turn the spindle on, and then push go one more time. As you can see, it's actually taking material on every cut because it is moving in at 29.5 degrees. So with the tool 10 thousandths smaller, it makes sense that it'll cut on every pass. Okay, everybody, so as you can see, I've got the part here in my hand now. It was really fun making this for you and showing you a little bit about how the EX control in the 1440 lathe works. I hope this is going to be really beneficial, especially for you guys out there in the learning environment. Until next time, in the next video, I'll see you. And don't forget, as always, remember to keep on tracking.